Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. Okay, so in today's class, we'll be seeing some numericals from this chapter circles. And to handle these questions with ease, you need to recall the theorems from class 9, okay, of the same chapter circles which you had in class 9. Okay, so let's see them first and then take up the questions. So in class 9, we have seen that angle in a semicircle is a right angle. Angle in a semicircle is a right angle. So if AB is the diameter, then angle ACB is equal to 90 degrees. Angle in a semicircle is a right angle. AB is the diameter. So angle ACB is equal to 90 degrees. Arc AB subtends angle AOB at the center. Arc AB makes or subtends angle AOB at the center. Now the same arc AB subtends angle, okay, angle ADB at the point D on the circumference of the circle. The same arc AB subtends angle ADB at the point D on the circumference of the circle, on the remaining part of the circumference of the circle. What do we mean by that remaining part? Because this is the arc which is subtending the angle. This is the arc AB which subtends angle AOB at the center and angle ADB at the point D on the remaining part of the circle. This is the remaining part of the circle. The part of the circle other than the arc is the remaining part of the circle. This one is the arc, right, which is making the angle at the center and making the angle on the circumference. The remaining part of the circumference will be the part of the circle other than the arc which is making the angle. Arc AB makes angle AOB at the center. The same arc AB makes angle ADB at the point D on the remaining part of the circumference of the circle. Now the relation between these two angles is, if I mark this angle 1 and this one 2, then I think it's not seen, angle 1 and angle 2, the relation between these two angles is that angle 1 is double angle 2. The angle at the center is double the angle formed on the circumference. Center angle is more. The angle made at the center will be more. So the angle at the center is 1, angle 1. Angle 1 will be double of angle 2. So if angle 2 is 30 degrees, angle 1 will be 60 degrees. If angle 1 is 100 degrees at the center, 100 degrees, then on the circumference, 50 degrees. On the circumference, the angle is small. Center, the angle is large. Center angle is double the angle on the circumference. So this you have to remember. Angle 1 is twice angle 2. Okay. Then in a cyclic quadrilateral, opposite angles are supplementary. In a cyclic quadrilateral, what is a cyclic quadrilateral? If the vertices of a quadrilateral lie on the circumference of a circle, Now you can see these 4 points A, B, C, and D. They lie on the circumference of the circle. So when you join these 4 points A, B, C, and D, the quadrilateral obtained is a cyclic quadrilateral. ABCD is a cyclic quadrilateral because the vertices A, B, C, and D lie on the circumference of a circle. Property: in a cyclic quadrilateral, opposite angles are supplementary. Angle B plus angle D is 180. Angle A plus angle C is 180. Okay. Angle A plus angle C is equal to 180. In a cyclic quadrilateral, opposite angles are supplementary. Okay. Then this is simple, but we often fail to realize that when we solve numericals from circles. So now AB is a chord, O is a center. AB is a chord, O is a center. This triangle is isosceles because OA is equal to OB, radii of the circle. OA is equal to OB. Therefore, triangle AOB is isosceles, which means this angle is equal to this angle. So, angle in a semicircle is a right angle. Angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the remaining part of the circle. In a cyclic quadrilateral, opposite angles are supplementary. We have a few more, like equal chords, subtend equal angles at the center. Now, we'll not do everything. I'll just tell you a few now. These are enough to solve the numericals, which, I have in this presentation. There are a few other theorems which we need to recall. We'll see that in the next class because I don't want to do too much of it today. And then we'll just see whatever is needed for today's class. Yeah. So angle in a semicircle is a right angle. Angle at the center, double the angle on the circumference. In a cyclic quadrilateral, opposite angles are supplementary. And this one is an isosceles triangle. So this angle is equal to this angle. And now this here in circles, we've seen this theorem. Tangent, point of contact, radius through the point of contact makes 90 degrees with the tangent. Tangent at P, PO is the radius through the point of contact. So now this radius and the tangent, they are perpendicular to each other. Okay, I think with this we'll just get started, and if I have missed out on anything, I'll just come back and do it for you. Yeah. Okay, these are quite simple, children. Okay, we'll just do this. See here. Yeah. In the figure, if angle AOB is 100 degrees, AOB, this one is 100 degrees, find angle BAT, BAT, this one. Just a minute. One second. Yeah. So AOB is 100 degrees. This is 100. Okay. We'll have to find BAT, BAT, this angle, this angle. So in this figure, OA is equal to OB, radius of the circle. So 180 minus 100, 80. So this is 40, this is 40. Now, this angle is 90 degrees. Which one? This is 90 degrees. Why? Because this is the tangent and this is the radius through the point of contact. A is the point of contact. AO is the radius through the point of contact. So the radius and the tangent, they are perpendicular to each other. This one is 90 degrees, but this one is 40 degrees. We just found this is 40. So this angle BAT will be equal to 90 minus 40, 50 degrees. We'll see it again. This is 100, given this is 100. Now this triangle is isosceles. So 180 minus 100, 80. This angle is equal to this angle because these two sides are equal. So 80 divided by 2, 40. This angle is 40 degrees. Now, this is 90 degrees. Now, this 90 degrees is made up of two angles. One is BAT, which we have to find BAT, and then this 40 degrees, which we just found. So how will you write? Angle OAB, not OAB, sorry. Angle OAT. Angle OAT is equal to 90 degrees. Okay. But what is OAT made up of? It's made up of OAB and BAT. Correct? OAB and BAT is equal to 90 degrees. OAB is 40. So plus BAT is equal to 90. So BAT is equal to 90 minus 40, which is 50. Children, in this 1 hour session, I do want you to write during the session, but we'll hardly do anything. That's why I repeated the explanation. I'll share the working. You have to complete it later. Only then we can really, make use of the session. Otherwise, we'll just end up doing 2-3 sums, and it'll not be worth enough for you also to spend 1 hour for 2-3 questions. So I'm sure all of you understood this. I'm going to the next one. QPT is 60 degrees. QPT, this one. This is 60 degrees. Okay, now I have to say this. Always connect the point of contact or the points of contact to the center. Always connect. See, without connecting, if you got the answer, fine. Otherwise, please connect. Please connect the points of contact to the center. Like get that isosceles triangle. Get that isosceles triangle. Okay, that's what I'm trying to say. We'll first read the info. QPT is 60 degrees. QPT, this one. This is QPT. This is 60 degrees. Okay. Find PRQ. PRQ. We need to find this angle. We need to find this angle. Okay. So without thinking much, just join. Okay. Just join OP. What to join? P is a point of contact, right? So join OP and OQ. We'll see if we have to join anything else later. Always get an isosceles triangle. Okay. All right. Now we know that, let me do it neatly. Okay. So children, see, we know from the radius to the tangent is 90 degrees. See, from the radius till the tangent, it's 90 degrees. Now, can you see this angle is 60 degrees? This one is 60. So that means this is 30. This one is 30. Because we know radius perpendicular to tangent. Okay, radius, see, OP is a radius. From there till the tangent is 90 degrees. But this angle is 60. So this is 90 minus 60, 30. Now this triangle is isosceles. So if this is 30, this is 30. Now 180 minus, okay, 30 plus 30, 60. 180 minus 60, 120. So this angle is 120. Okay, this angle is 120. You can do this in 2-3 ways. One of the methods is you can just take a point here. you can just take a point here on the circumference and join, say, let me call it M. Okay. Take a point M anywhere on the circumference. Take a point M, join P to M, Q to M. Now you can see the cyclic quadrilateral PRQM. PRQM is a cyclic quadrilateral. Now, by the theorem, we know that if the angle at the center is 120 degrees, then on the circumference it will be half, so 60 degrees. Because they're made by the same arc. You can name the angle and make out. Name this angle 120 degrees, angle POQ. So it is made by the arc PQ. Name the angle on the circumference, angle PMQ. PMQ. So see, that also is made by the same arc PQ. Name the angles. You will make out which arc, subtends those angles. Name the angles. So from the names, you can make out that angle POQ is the angle subtended by arc PQ at the center O. The same arc PQ makes an angle PMQ on the circumference at the point M. So if this is 120, this is half of it, 60 degrees. Now we know in a cyclic quadrilateral opposite angle is supplementary. So this is 120. In a cyclic quadrilateral, opposite angle is supplementary. So it is 120. We'll do it again. Join. Okay. We need to get a triangle, an isosceles triangle. This is 90. This is 60. So this is 30. So this is 30. So this is 120. You can use the theorem. The angle in the center is double the angle on the circumference. For that, you should find this angle. See here? Okay, we just recall what we just learned. This is 120. Then I said, mark a point anywhere on the circumference. Join. So this is made by arc PQ at the center. This is made by the same arc PQ on the circumference. So this is 60 degrees. Now we see that the points P, R, Q, M all lie on the circumference. So P, R, Q, M is a cyclic quadrilateral. Opposite angles are supplementary. So if this is 60, this is 120. The other way of doing it is, we got 120 here, right? 120 here. You should find the reflex angle. This is 240. This is 240. So the major arc PQ subtends angle 240 degrees at the center. The same major arc PQ. See, the arc should not subtend an angle on itself. That's why we say remaining part of the circumference of the circle. The major arc PQ subtends an angle at the remaining part of the circle at this point R. See here? The major arc PQ subtends angle PRQ at the point R on the remaining part. See, if this is the remaining part, no? This is the remaining part of the circle. Because that yellow thing is the major arc. So this red one is the remaining part of the circle. And you can see R on the remaining part of the circle. So the same arc PQ subtends PRQ. See here, POQ, PRQ. POQ. Angle POQ is equal to 240 degrees. Angle PRQ. And you can see that R is a point on the remaining part of the circle. It's on the minor arc. PQ is the major arc. So you can see that the other part is the minor arc. And R is a point on the minor arc. So the same arc PQ subtends an angle PRQ at the remaining point on the circumference of the circle. So if this is 240, this angle will be 120. So you can use a theorem and do it straight away without having to construct the cyclic quadrilateral. But we go wrong here. Sometimes what we do know, this is 120, so we say this is 60. In order to avoid that mistake, I also share this idea about the cyclic quadrilateral so that you can't go wrong there. So this method I said, this is 120. Find the reflex angle. So this is 240. This angle, this red arc subtends this angle at the center. This angle at the center, 240. The same arc. This is the remaining part of the circle. This one is the remaining part of the circle. And this is the point R on the remaining part of the circle. The same arc PQ subtends PRQ at the point R on the remaining part of the circle. So if the angle at the center is 240, this is half of 240, which is 120. So PRQ is 120. QPT is 50 degrees. QPT, okay, that's marked. Find POQ. So how much is POQ, children? How much is POQ?
100 degree.
100. Correct. 100. Because radius, tangent, 90 degrees. See, radius, tangent, 90 degrees. This is 50. So this will be 40. This is an isosceles triangle. These two sides are equal. So this also will be 40. 40 plus 40, 80. 180 minus 80, 100. $90 minus 50, 40, 40, 100. Angle some property in a triangle. PAB is 71 degrees. PAB is 71. Okay. AQB. AQB. This one. Okay. So we'll always have, more than one way of working. So you can, like after the class, I'll share the images, the question images. Try to do it by yourself. Try to recall and do it by yourself. I'll not share the answers. I'll share only the question images. Try to do it by yourself. Recall as much possible. Then maybe I'll check with you tomorrow if you had time to try. I'll share the answers after some days. Anyways, I think you must have finished all your exams by now. With the puja vacations around the corner. Yeah, so I'll share only the question images. You please try to do it by yourself. And then I'll share the answer images. Yeah, here 71, and we need to find AQB. So always, children, please connect that. I told you, we don't know if we need it, we don't need it, we don't know. See, how do you know? It's not a theory question, right? That you have the answer fixed, ready in your mind, and you just have to write it. So you don't know, but join it. Join. So you have an isosceles triangle. Okay, so now this is 90. Yes, this is 90. Okay, 1 minute. Let me just think about the different ways available. So while you think, even I'll think. Yeah. Okay, I got one way of doing it. I think that will be the shortest. Okay, you can use the exterior angle property. You can use the exterior angle property. So this is 90, right? From here, radius tangent 90 degrees. This is 71. So this is going to be 90 minus 71, 19 degrees. But OAB is an isosceles triangle. This side is equal to this side. So this angle is also 90 degrees. Okay, so this is 19. So we got 19. Now, let's do it again. Now, this is 19, okay? This is 19. So I'll mark this AQB as X. Now, by the exterior angle property in a triangle, okay, AQB is a triangle, and the 71 degrees is the exterior angle. So exterior angle 71 is equal to the sum of the two interior opposite angles, 19 plus X. So X is equal to 71 minus 19, 61, 51, 52. 52 degrees. So join OA, 71 given, 90, 90 minus 71, 19. Isosceles triangle. So this is also 19. Then exterior angle property. See, if exterior angle property does not occur to you, then you can anyways do it like this. This is 71, no? So you can find this by linear pair. You can find this one by linear pair. And you got this one is 19 degrees. So you will find this by linear pair, right? So this angle, you know this angle, you know this is 19, plus this angle X is equal to 180. In the triangle, the sum of the three angles is 180. You can always do it like that. But you should be able to identify the exterior angle property. If this is 71, you can find this using linear pair axiom. And then we know this is 19. So this angle plus 90 plus X is equal to 180. You can also do it like that. PQ is 58. PQB. PQB, this one. Yeah. Let me ask you. Should we join? Okay, what should we join? Okay, we should join. What should we join? Have you learned the alternate segment theorem, children, in school? Alternate segment theorem. No, right? No. Yeah. So earlier we used to do a lot by the alternate segment theorem. See here. Now I don't use that. I'm not using that now because now that the syllabus, a lot of things are deleted, I don't want to use this. That's why I'm not sure. Actually, I'm not using the answer images because most of the answers I've done using alternate segment theorem. We're not doing using that now. That's why this construction and all that. Yeah. So join OP. So there's one thing which we know, no? Always join OP. So now tell me, this is 90, right? So how much is this angle? 90 minus 58. 32. How much is this one? 32. That's all. PQB is 32. 58, 90. Radius perpendicular to tangent. 90 minus 58, 32. Isosceles triangle property, 32. Finished. This one I had already done one class earlier. We'll just see it again, or we'll come back later. Yeah, this is the next one. ATB. Find ATB, this angle. So, like all the theorems should come to your mind. You must look for meaning you must check if there's a diameter, if you can see a diameter. If there's a diameter, you must see if you can mark angle in a semicircle as a right angle. Then check for radius and tangent to mark 90 degrees. Isosceles triangle. Everything should come to your mind. Then angle at the center, double angle on the circumference, everything, all that should come to your mind. Okay, so since this angle is given, which is at the center, children, okay, this angle is given, which is at the center. Name this angle. Children, name this angle. Angle. Please name the angle. AOQ. 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 Does the same, okay, which is the arc that subtends AOQ at the center? Which is the arc that subtends AOQ at the center? Arc. Arc AQ. Arc AQ subtends angle AOQ at the center. Now identify an angle made by the same arc on the remaining part of the circumference.
Angle ABQ.
Very good. ABQ. Very good. Angle ABQ. Angle ABQ. B is a point on the remaining part. See, this is the arc no AQ. The rest of the circle is the remaining part of the circle. This is the arc AQ. The rest of the circle is the remaining part of the circle. So on the remaining part of the circle, we have this point B. And this arc AQ subtends ABQ at the point B on the remaining part of the circle. So what's the relation between these two angles? AOQ, ABQ. What's the relation? This is double. So what's the value of this angle? Yeah, how much is this? 29. 29. 58 by 2, 29. What's the measure of this angle? Here, 90. Why? Radius perpendicular to tangent. So in triangle BAT, this is 29 degrees. This is 90 degrees. So you can find this using angle sum property. You can find this using angle sum property. This is 58. AOQ is 58. So ABQ will be 58 by 2, 29. So in this triangle, which triangle? This triangle. Now forget all this. All this is not there. Okay, so see this triangle. In this triangle, BAT, three angles. This is 29. This is 90, radius perpendicular to tangent. So angle sum property, you can find this angle, which is ATB. Yeah. Always join, children. Join OQ. Now tell me, is OQPR a cyclic quadrilateral? OQPR. Is it a cyclic quadrilateral? No, it is not, because the points Q and R, they lie on the circle. But O and P don't lie on a circle. But still, can you say it's a cyclic quadrilateral? Okay, fine. Though, the points O and P, children use the emoji, raise your hand. Swati, Niveda, Hari Pranav, Mitsa, Kamalika, Bhavishya, Pratish, Javarshini, Tanishka, Renu, Blessy, Srivatsan. Okay. Now, in your NCRT book, the second chapter, sorry, second exercise 10.2, we have seen that, we have seen that the quadrilateral, which is, formed by the tangents from an external point of the circle and the line segments connecting the points of contact to the center, that is a cyclic quadrilateral. Why? Because this is 90 degrees, no? Radius tangent 90, radius tangent 90, 90 plus 90, 180. So 90 plus 90, this also will be 180. This figure, you should identify the figure correctly. See here. P is the external point. PQ and PR are the tangents to the circle from the same external point P. PQ and PR are tangents to the circle from the same external point P. QO and RO, they are the line segments joining the points of contact to the center. Now, this quadrilateral is a cyclic quadrilateral. That is, there is a different circle that can be drawn passing through these 4 points. From this figure, we know this result. I'm saying we know this result. So you can use that result here. You can also do it without using that result. First, I'll tell you using the result. You can also do it without using that result. Now, this quadrilateral OQPR is a cyclic quadrilateral. Yeah, the points O and P, they don't lie on the surface of this circle. But you can draw a circle passing through these points O, Q, P, and R. You can draw a different circle passing through these 4 points O, Q, P, and R. Because we know such a quadrilateral formed like this, formed like what? By the 2 tangents from the same external point and the line segments joining the points of contact to the center. So the quadrilateral formed by these 4 line segments is a cyclic quadrilateral. So if this is 30 degrees, this is 150 degrees. This is 150. Okay. If this is 150, 180 minus 150, 30. So these two will share 15, 15. Okay. Now, if this is 150, this is going to be 75. Correct? Correct, children? QOR, QSR. QOR, QSR. Now, this is 90 degrees. This is 90. This is 15. So this is 75. Then alternate angles are equal. Parallel line, transversal, parallel line. If this is 75, this is 75. So now in this triangle QSR, this is 75, this is 75. So X will be 30 degrees. X will be 30 degrees. We'll see it again. Join. OQPR is a cyclic quadrilateral. You can use that result because we have it in the textbook. We can use that result. OQPR is a cyclic quadrilateral. So this is 150 degrees. Opposite angle is supplementary. This is 150. This we know is 90. Radius tangent 90. Now in this triangle, these two sides are equal. So 30 by 2, 15 degrees. This is 15 degrees. 15. So 90 minus 15, this is 75. This is 75. So parallel line, transversal, parallel line. If this is 75, this one, see parallel line, transversal, parallel line. If this is 75, this is 75. So this is 75. In the triangle, this is 75 degrees. Now, by the theorem, angle at the center is double the angle on the circumference. If this is 150, this is 75. Now in this triangle QSR, two angles are 75 degrees each. So this X, the angle which is marked X is 180 minus 150, which is 30. Okay. You can just think of other ways. I told you, it's just that you have to keep all the theorems in mind. You should just keep checking with, the theorems. No point just staring into the figure like we keep staring into the figure without running any theorem in your mind. You should do both at the same time. You must stare at the figure and run the theorems in your mind. It's not looking at the figure from different angles. We'll not get the answer. So just put a theorem in your mind. Is there a diameter? So that angle in a semicircle is right angle. No, it's not there. Then is there an isosceles triangle? No, it's not there. Radius perpendicular to tangent. Okay, let me join. So like that, you should run the theorem in your mind and apply it in the figure. Then is there a cyclic quadrilateral so that we can say opposite angles are supplementary? Is there an arc which makes an angle at the center and an angle on the circumference? So like that, keep running the theorems in your mind and apply it in the figure. So that way you will be able to crack it easily. We'll do this one now. We'll do this. We'll just do this, and this one looks kind of similar to the earlier one. We'll do this and come back. Yeah, let me get it from you. Find angle QSR. Sorry. Find angle QSR. Okay, let me help you like this. QSR is this angle, okay? This full angle. This is QSR. So it's made up of two angles. So find this, add both. Find this angle, and add both. Yeah, now it's easy, children. How much is this? I already marked it. What's the magnitude of this angle? What is the magnitude of this angle?
90.
90. How much is this? 60. Then, yeah, how much? Yeah, so what will be the measure of this angle?
30 degrees.
30. And then, are these two sides equal? Yes. So what will be the measure of this angle?
30 degrees.
30. 30. Now we found this part. Now come to this side of the figure. What's the magnitude of this angle? Radius tangent. See, from the radius till the tangent. How much is this? 90 degrees. This is 50. So how much is this?
40 degrees.
40. Again, isosceles triangle, right? Because OQ radius, OS radius. So these two sides are equal. So this angle is 40, so this also will be 40. So now what is QSR? QSR equal to 70 degrees. 30 plus 40, 70 degrees. So see that isosceles triangle property. We don't realize that, then this is going to be really hard. Let's see it again. See radius OR and tangent 90 degrees. This is 60. So this is 30. OSR is an isosceles triangle. So if this is 30, this is 30. Now here again, this is 90 degrees. From the radius till the tangent is 90 degrees. This is 50. So this is 40. Again, isosceles triangle. Radius OQ, radius OS. So this side is equal to this side. So this angle is 40 degrees. This is also 40. So QSR is 30 plus 40, 70. Yeah, we'll try this. TPQ. TPQ 70. Find TRQ. So join what, children? Join join OQ OT. Join OQ and OT. Okay. Now identify this. OTPQ is a cyclic quadrilateral. Why? Because it's a quadrilateral with the tangents from the external point to the circle and the two line segments joining the points of contact to the center. TO, TO, sorry, TO and QO are the line segments joining the points of contact to the center. And P is external point, PT and PQ are the tangents. So the quadrilateral formed by these four line segments is a cyclic quadrilateral, which makes this 110 degrees. 70 plus 110 is 180. Now, angle in the center is double the angle on the circumference. So this is 55 degrees. The angle TRQ is equal to 55 degrees. TRQ is 55. First, we need to join TO and QO. Then say it's a cyclic quadrilateral. So the angle at O is 110. This arc angle QOT is 110. So angle QRT will be 55. 110 by 255. QOT, QRT. Okay, the others maybe I'll just give it. Okay, we'll do this one. Okay, we'll do this one today. Find the measure of angle PTA. PTA, this one. PTA. See, this also because we have a lot of information. You can see the diameter AB. So angle in a semicircle is a right angle. We also know radius perpendicular to tangent. So they're 90 degrees. So one of the ways can be, you can see arc, angle PBA. PBA. this arc PA subtends PBA on the circumference. The same arc PA subtends POA at the center. Look at that, PBA, POA. PA is the arc. It makes PBA on the circumference. POA at the center. So this is how much? How much will be the angle at O?
60.
60 degrees. 60 degrees. Now, supposing your idea is to find this one by angle sum property in a triangle, okay? So you want to find this, say, using angle sum property. We've got this is 60, and you want to find PTA. This is the angle which we need to find. And say you want to find using angle sum property in this triangle. Okay, what's the measure of this angle? What is the measure of this angle? What's the measure of this angle?
90 degree.
90 degrees. 90, because OP is a radius. PA is a tangent. So OPA is 90. OPA. Oh, sorry, OPT. Sorry, I'm sorry. OP is a radius. PT is a tangent. So this angle is 90 degrees. So 90 plus 60, 150. 180 minus 150, this is 30. You can also think of doing it in a different way, like, this is 30, right? You please think like that. So like this is 30, these two sides are equal, so this is also 30. And then angle in a semicircle is a right angle, so this one is 90 degrees. Just go ahead like that. One thing will lead to another and just try to do it like that. Just tell you what we just did. We said this is 30 degrees, so this is 60 degrees. And we used this triangle to find this angle. This one is 90 degrees because radius perpendicular to tangent. So 90 plus 60, 150. 180 minus 150, 30. All right. All right, children. We'll just wind up today's session with this one. Yeah, we just do this and let's see here. All my presentation has angle segment theorem. AB is parallel to PR. AB is parallel to PR. BQR is 80 degrees. AQB. Similar to the one which we did here. This one, not this. We did one like this, no? Oh, where did that go? Not so far. Didn't we? Then did we do this already? There was a next, no, in the figure. Oh, this one, shit. This one. Sorry. Yeah. Okay. AB parallel to PR, children. And BQR. BQR, this one, is 80 degrees. Find AQB. AQB. This angle. So parallel lines, you can use alternate angles are equal. I don't know if I should say or you can just try to do this by yourself. Similar to the earlier one. Kind of you can use those ideas. Like you can see it, there's 90 degrees, there's parallel lines, so alternate angles are equal. And then this is 90 degrees, this is 90, but this is 80, so the rest of it you can find. So just work like that. If you want, you can join this OB. I think you can just try to do this by yourself. We'll see the answer tomorrow. All right. All right. So now, in some time, I'll share the question images with you. Try to, roughly work out the answers for them. I'll share the answers later in some 2 days' time. All right. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.